Hello, my dear students. Today we are going to continue our discussion in chapter 2, which is chemical analysis. The last episode we have finished the discussion on detection of acidic radicals. Today we are going to discuss detection of basic radicals, which are going to discuss 6 analytical groups. In our syllabus we are going to detect 4 groups only. So let us start. Detection of cations, or we can say detection of basic radicals. We have to give reason for this point. Identification of basic radical is more complicated than the detection of acidic radicals. The reason for that, there are large number of basic radicals and each cation has different oxidation states. The identification of cations is divided into 6 groups that called analytical groups. Each analytical group has its own reagent depending on the solubility of the metal salt in water. The scientific base of identification of cations is forming colored insoluble salt for the detected metal. The first analytical group. The group reagent of the first analytical group is dilute hydrochloric acid. The precipitate that is formed for this group is chloride salt. What are the studied cations of this group? Mercury Hg positive 1, silver Eg positive 1, and lead 2 or lead positive 2. Bb positive 2. The second analytical group, the group reagent of this group is hydrogen sulfide gas in the presence of dilute hydrochloric acid. The precipitation of the salt here is sulfide salt. The studied cations of this group is one of the cations that we are going to discuss this year is copper 2 or copper positive 2. Now we are going to test for copper 2 ion. The salt solution plus hydrogen sulfide gas in the presence of dilute hydrochloric acid is the reaction to detect the cation of this group, which is copper ion. As the following animation will show, we are going to prepare hydrogen sulfide gas. This is done by the reaction of concentrated hydrochloric acid and iron 2 sulfide in order to produce the group reagent here, which is hydrogen sulfide gas, that react with the salt solution here to detect it, as the following animation show. As shown on the screen here, we bring copper sulfate solution to detect the presence of copper ion, and we are going to pass over it hydrogen sulfide gas. The reaction proceed as following on the screen, as shown on the screen, as the hydrogen sulfide gas is bubbled on the copper sulfate solution. The reaction proceed giving sulfuric acid and copper sulfide, which is black precipitate. As shown on the screen, the black precipitate starts to form as the reaction continue and giving black precipitate of copper sulfide, indicating that the presence of copper positive 2 in the solution and forming copper sulfide black precipitate. So, my dear student, the black precipitate of copper 2 sulfide is formed, which is soluble in hot concentrated nitric acid. As the equation proceeds on the screen, copper sulfate solution plus hydrogen sulfide gas giving sulfuric acid aqueous solution plus black precipitate of copper sulfide. The third analytical group. The group reagent of third analytical group is ammonium hydroxide. Here, my dear student, The precipitation here is metal hydroxide, which is insoluble in water. Here the studied cations of this group is aluminium ion, aluminium positive 3, and iron 2 ion, which iron Fe positive 2, and iron 3, which is Fe positive 3. Now we are going to discuss each ion in detail. We are going to discuss its main test and confirmatory test. So we are going to detect first the aluminium positive 3 ion. So the main test here is a salt solution plus ammonium hydroxide solution. Here it gives white precipitate as the following animation show. If you look at the screen solution here of aluminium chloride, and we are going to add ammonia solution, which is ammonium hydroxide, as the ammonia dissolves in water, giving ammonium hydroxide solution. Here gives white gelatinous precipitate of aluminium hydroxide as shown on the screen. If you are going to add sodium hydroxide on this precipitate, it will disappear. Now the formation here of aluminium hydroxide indicating that the presence of aluminium ion in aluminium chloride. So my dear student, the produced precipitate is white gelatinous precipitate of aluminium hydroxide, which dissolves in dilute acids and caustic soda, which is sodium hydroxide. As the equation proceeds on the screen, if you bring aluminium sulfate or aluminium chloride, any salt contain aluminium ion plus ammonia solution, which is ammonium hydroxide, it gives ammonium sulfate soluble in water and white gelatinous precipitate of aluminium hydroxide as shown on the screen. Now we are going to discuss the confirmatory test for detection of aluminium positive 3 ion. The salt solution plus sodium hydroxide also give white gelatinous precipitate of aluminium hydroxide, which is soluble in excess of sodium hydroxide as formation of sodium meta-aluminate, which is soluble in water, as the following animation show. Here, my dear student, we have salt solution of aluminium as aluminium chloride, and we are going to add over it sodium hydroxide solution using a dropper, and we are going to put the solution of caustic soda or sodium hydroxide on the aluminium salt solution, which is aluminium chloride solution. We observe the white gelatinous precipitate of aluminium hydroxide. This white gelatinous precipitate of aluminium hydroxide, if you add excess amount of sodium hydroxide over it, the reaction of aluminium hydroxide and sodium hydroxide gives sodium meta-aluminate, which is soluble in water. So we observe that the white gelatinous precipitate disappear and the solution turns clear again, as shown on the screen. So my dear student, the produced precipitate is white gelatinous precipitate of aluminium hydroxide, which is the same that produced by the main test. Here it dissolves in excess of sodium hydroxide due to formation of sodium meta-aluminate NaLO2. As the equation proceeds on the screen, of using aluminium sulfate as salt solution of aluminium ion plus sodium hydroxide, it gives sodium sulfate and white precipitate of aluminium hydroxide AlOH all 3. Then when adding excess of sodium hydroxide solution NaOH solution to the precipitate here of aluminium hydroxide, here gives sodium meta-aluminate NaAlO2, so is soluble in water and the white gelatinous precipitate disappears and water is produced as shown on the screen. Now we are going to discuss the second ion of the third analytical group, which is iron 2 ion or Fe positive 2. So the main test, like the main test of aluminum ion is adding the salt solution to ammonium hydroxide solution. Here we are going to show the precipitate of iron 2, which is white green precipitate, as the following animation show. Here, my dear student, we use solution of iron 2 as iron 2 chloride, and we are going to put some of it in a test tube, and we are going to bring ammonia solution, dissolved ammonia in water. It gives here white green precipitate as shown on the screen due to formation of iron 2 hydroxide. So, my dear student, the produced precipitate is formed first white precipitate, but turns white green precipitate when exposed to air, and it's soluble in acids. So the equation proceed on the screen now. The iron 2 salt solution is iron 2 sulfate. When reacts with ammonia solution, ammonium hydroxide, here giving ammonium sulfate NH4O2SO4 and white green precipitate of iron 2 hydroxide as shown on the screen. Now we are going to discuss the confirmatory test. Here, my dear student, the confirmatory test here is using the salt solution plus sodium hydroxide solution as we did with aluminum ion. Here the reaction gives also white green precipitate of iron 2 hydroxide as the following animation show. As shown on the screen, we bring iron 2 chloride or iron 2 sulfate, any iron 2 salt, and we add sodium hydroxide on it. Here, my dear student, if you look at the screen, you will see the formation of iron 2 hydroxide, which is white green precipitate. So the equation proceeds on the screen. Iron 2 sulfate solution plus sodium hydroxide solution gives sodium sulfate and iron 2 hydroxide, which is white green precipitate. Now we are going to discuss the third ion for the third analytical group, which is iron 3 ion. Again, my dear student, we are going to discuss the main test, which is using the salt solution plus ammonium hydroxide solution. It gives reddish brown precipitate of iron 3 hydroxide as the following animation show. As the equation proceeds on the screen, iron 3 chloride plus ammonium hydroxide gives ammonium chloride and iron 3 hydroxide precipitate or insoluble salt in water, which is reddish brown precipitate. Here, my dear student, if we use the ammonia solution and we are going some of it on iron 2 chloride or iron 3 chloride, we detect each one. Now we are going to detect iron 3 chloride solution. So if we put the ammonia solution on iron 3 chloride solution as shown on the screen, it will give reddish brown precipitate of iron 3 hydroxide. As shown on the screen, the precipitate is formed of iron 3 hydroxide as adding sodium hydroxide or ammonium hydroxide on it. So the produced precipitate here is reddish brown gelatinous precipitate, which is iron 3 hydroxide, which dissolves in acid. As the equation proceeds on the screen, iron 3 chloride plus ammonium hydroxide, it gives ammonium chloride and iron 3 hydroxide FeOH all 3 as shown on the screen. Now we are going to discuss the confirmatory test. Here, my dear student, the confirmatory test by the salt solution with sodium hydroxide solution as previous cations of the third analytical group. Here, the produced precipitate is a reddish brown precipitate of iron 3 hydroxide as the following animation show. Here we bring iron 3 chloride as iron 3 salt solution, and after adding sodium hydroxide solution on it, we observe the formation of iron 3 hydroxide, which is reddish brown precipitate as shown on the screen. So, my dear student, the equation of the reaction iron 3 chloride plus sodium hydroxide, it gives sodium chloride and reddish brown precipitate of iron 3 hydroxide, FeOH3. Now, my dear student, we are going to discuss the fifth analytical group. We didn't have fourth analytical group. We are going to discuss the fifth analytical group. The group reagent for the fifth analytical group is ammonium carbonate. The precipitation that happens here of adding ammonium carbonate to the salt solution, it gives metal carbonate which is insoluble in water. The studied cations of this group is one of the cations. Here is calcium ion, calcium positive 2. So we are going to discuss the test for calcium positive 2. Now the main test is the salt solution plus ammonium carbonate solution. We observe that white precipitate of calcium carbonate which dissolves in dilute hydrochloric acid and water containing carbon dioxide gas. Here the animation shows the reaction. So my dear student, if we add the ammonium carbonate on the calcium salt solution, we observe white precipitate of calcium carbonate as shown on the screen. So my dear student, as shown the equation here, calcium chloride solution plus ammonium carbonate gives ammonium chloride and the calcium carbonate. This calcium carbonate soluble in solution containing carbon dioxide. Here, my dear student, the confirmatory test. The salt solution plus dilute sulfuric acid. Here, my dear student, the produced precipitate is white precipitate of calcium sulfate. As the equation proceeds, calcium chloride plus sulfuric acid giving hydrochloric acid solution and calcium sulfate which is white precipitate as the following animation shows. So as shown on the screen here, the formation of white precipitate after adding the sulfuric acid on calcium salt, that forming white precipitate of calcium sulfate. Now we are going to discuss the dry test, or we can say the flame test for calcium ion. The volatile calcium ion in the Bernsen flame gives brick red flame as the following animation show. As shown on the screen, calcium chloride on platinum wire in non-luminous flame, it gives brick red flame indicating the presence of calcium ion in the salt. This illustrates that the detection of calcium ion in the flame test as shown on the screen. Now, my dear students, we are going to discuss some revision on chemical calculation. The mole. It is the amount of matter that contains Avogadro's number, which is 6.02 times 10 power 23 of atoms or molecules or ions or formula units of the substance. Now we are going to discuss some examples. Aluminium ion positive 3 plus 3 electrons give aluminium. Here 3 moles of electrons needed for reduction of 1 mole of aluminium ion to form 1 mole of aluminium atoms. What do we mean by the molar mass? It is the molecular mass of the substance expressed in grams. How can we find the molar mass of the molecules? Examples. How can we find the molar mass of oxygen gas? As the atomic mass of oxygen equals 16. The answer here, the molar mass of oxygen as it is diatomic gas, so 2 times 16 equals 32 gram. Another example, here we can get the molar mass of molecules of compounds like carbon dioxide, the atomic mass of carbon is 12 and the atomic mass of oxygen is 16. So how can we find the molar mass of carbon dioxide? By getting the sum of the atomic mass of carbon dioxide. So 1 times 12 plus 2 times 16 equal 44 gram. Another example, the molar mass of sodium carbonate. As the molecular formula of sodium carbonate, Na2CO3, where the atomic mass of sodium equal 23 and carbon 12 and oxygen 16. So the answer here, the molar mass of the chemical formula of sodium carbonate, Na2CO3, equal 2 times 23 plus 1 times 12 plus 3 times 16 equal 106 gram. Now, my dear students, we are going to discuss some questions. The first type of questions, choose the correct answer. Salt solution plus sodium hydroxide solution produce reddish brown precipitate. Is it calcium, iron 3, aluminum, iron 2? If you think about it, my dear student, yes, it will be iron 3, as the formation of iron 3 hydroxide, which is reddish brown precipitate. Next point, salt solution plus sodium hydroxide solution produce white green precipitate. Is it iron 2 or aluminum or calcium or iron 3? If you think about it, yes, the answer it will be iron 2. The reason is the formation of iron 2 hydroxide, which is white green precipitate. Next point, salt solution plus dilute hydrochloric acid and hydrogen sulfide gas giving black precipitate. Is it calcium or iron 2 or iron 3 or copper? If you think about it, my dear student, yes, the answer it will be copper, as the formation of black copper oxide. Next point, salt solution plus sodium hydroxide solution produce white gelatinous precipitate. Is it calcium or iron 2 or iron 3 or aluminum? If you think about it, my dear student, yes, the answer is aluminum. The reason is the formation of aluminum hydroxide, which is white gelatinous precipitate, which dissolves in excess of sodium hydroxide due to formation of sodium meta-aluminate, which is soluble in water. Next point, salt solution plus ammonium hydroxide solution produce reddish brown precipitate. Is it calcium, iron 3, aluminum, iron 2? If you think about it, yes, the answer it will be iron 3. The reason is the formation of iron 3 hydroxide, which is reddish brown precipitate. Next point, salt solution plus ammonium hydroxide solution produces white green precipitate. Is it iron 2 or aluminum or calcium or iron 3? If you think about it, yes, the answer it will be iron 2 hydroxide, which is white green precipitate. Next point, salt solution plus ammonium hydroxide solution produces white gelatinous precipitate. Is it calcium, iron 2, iron 3, aluminum? If you think about it, yes, the answer it will be aluminum. This is due to the formation of aluminum hydroxide, which is white gelatinous precipitate. Next point, calcium gives what color in the dry test? Is it pale violet, yellow, blue, brick red? If you think about it, my dear student, yes, it will be brick red. Next type of question, write the scientific term for the following. My dear student, from the following experiments, deduce the salt name and its chemical formula without writing the chemical equation. On adding lead to acetate solution to the salt solution, white precipitate is formed. And on adding ammonia solution to the salt solution, a white gelatinous precipitate is formed. If you think about it, my dear student, you will find that this question contains two types of radicals, acidic radical and basic radical. So the detection by using lead to acetate, it gives sulfate radical, and the use of ammonia solution and giving white gelatinous precipitate is aluminum radical. So the salt is aluminum sulfate, which has chemical formula Al2SO4O3. Next point. On adding silver nitrate solution to the salt solution, white precipitate is formed. And when turns to violet when exposed to light. And on adding ammonium carbonate solution to the salt solution, white precipitate is formed. If you think, my dear student, about the answer of this point, you find that there are two radicals we are going to detect here, acidic radical and also basic radical. Here, the use of silver nitrate giving white precipitate that turns violet is chloride ion, which is acidic radical. And on adding ammonium carbonate giving white precipitate is the test for the basic radical, which is calcium. So the salt here is calcium chloride, and the chemical formula CaCl2. Next type of question, how can you differentiate between sodium chloride and calcium chloride? Here the experiment, my dear student, dip platinum wire in concentrated hydrochloric acid to clean it. Then dip it in the solid salt, and put it in the benzene flame. Here's the observation. If brick red flame is observed, the salt is calcium chloride. But if the golden yellow flame is observed, the salt is sodium chloride. My dear students, we have reached to the end of our program today. I hope you understood all the points and experiments that we have discussed today. So till we meet again, my best wishes for you.